MECH 2409 Group Design Project Disc Brake by Ahmed Mehdi, Basil al-Sharif, and Mohammed Sharif. Today we will be presenting our loading conditions as well as our final design for our MECH 2409 Group Project. Preliminary Design. This is our preliminary design. The disc brake has holes for better ventilation and was made thin in order to reduce weight. We chose to use cast carbon steel for the rotor, and for the brake pad, we chose to use semi-metallic material. We also designed the caliper, piston, pin, and the brake pad, which we modeled in SolidWorks. The brake caliper is made of aluminum to reduce weight. Boundary conditions. The boundary conditions for our design were defined by the surface area of the brake pad that were in contact with the disc rotor. Static loading conditions, preliminary design. For our static loading conditions, we applied a force of 13.8 kilonewtons to the contact area on the rotor from the brake pad, which is 6.9 kilonewtons on each side, compressing the rotor. This loading condition was calculated to stop our vehicle at a max speed of 300 kilometers per hour within 5 seconds. The max speed and braking time were obtained from our research on Formula vehicles. These times and speed are considered typical in Formula vehicles.
Cyclical loading conditions. Preliminary design. For our cyclical loading conditions, we applied a force of 6.25 kilonewtons, distributed on both sides of the rotor in compression, and we analyzed this force for 300 cycles. We obtained the force through research. Through research, we found that a typical hard brake is a brake from 45 meters per second to a dead stop in 6 seconds. We also found that a vehicle can withstand approximately 300 cycles of these hard brakes on average. Static loading conditions, final design. For our final design, we made changes to the disc rotor and analyzed the same static loading conditions on our updated design.
Cyclical loading conditions, final design. The same was done for our cyclical loading conditions for our final design. We updated our rotor and analyzed the updated rotor under the same cyclical loading conditions to look for better performance. Final design. This is a photo of our final design in the orthogonal view. We modified the rotor thickness to 1 inch from an initial 0.5 inches. We also updated the caliper width to adjust for this change. These changes made our design safer and increased the factor of safety from 57 to 60 under static loading conditions. The design also had infinite life cycles, according to our FEM analysis, although this might be different in real-life application. Ultimately, the safety was increased and the weight was increased slightly, although this is okay, as safety is our most important priority. Thanks for listening.